Hello. Hi, everyone. Sorry, I joined late. I was having some network issues. Okay, so let's get started. So yesterday we discussed Spark, and I explained the various modules uh, available in Spark. So as we can see here, we have Spark core module, we have Spark's data frames that is used for batch application. We also have uh, Spark streaming module that is used for real-time application. Then comes the graph module that is used for developing graph application. And then last is the analytical module or Spark ML module or ML module to develop analytical application. Okay. So let me show you the environment. So this is the Databricks environment here. So locally we can set up Spark on our local. So start PySpark shell. And here we can write our PySpark codes. Also, we can set up Spark environment on cloud as well. So if we go on cloud, so this is Databricks is the community that develops Spark on cloud. So here we can create our account on the community edition. So this is the after login, this is the home screen for this Databricks Spark. And here we can create our Spark cluster. So just click on this button and then give your cluster name, give any random name, create compute, and it will spin up the Spark cluster automatically. So once Spark cluster is set up, then we can execute our Spark notebooks or Spark jobs in this cluster environment. So right now it's setting up. So once this cluster sets up, then here we can create a this is my workspace, and here we can create our notebook. So let's create one notebook. Give this notebook a random name. So it's a Spark. uh, and here we can write a Spark code. So let me check the script. So we can choose one PySpark notebook and execute. Let's use this Spark Python. It's reading from database only. So execute any of the script. This is the customer file. Okay, let's execute this. Now we need to provide our job this data path. So here on Databricks we have data, you can say module. So this is called DBFS, Databricks File System. So here we can upload our file. So just upload. I have already uploaded this customer CSV file. So we can give the path of the file. This is customer.csv, copy the path. Path here. Okay. So now this text file function here, we provide the data path, it returns RDD, and then this in the next line we apply the map function that is doing split based on the comma, returns RDD. Then we again apply a map function that will map all the column values to these column names. So uh, name, city, and ID. These are the three columns. It returns RDD. Then using the SQL context. So SQL context provide a function called create data frame. Here we pass uh, the data along with the yeah, schema we already mapped. So yeah, so data we need to pass. So let me execute this. First, we need to connect our cluster. So this cluster is now up and running. Choose the cluster and then run it. So now job is running. So here it's failed due to Spark context. So this object is already available. So there's no need to create this object. In Databricks, it's already available. So let's remove this object, save it, and then rerun again. Now it's running. Okay. Now we can view the stages. So here we can see the stages that executes. So this is how we run jobs on the Databricks environment. We can run the same job on local as well. So we just need to submit this job using Spark Submit. Spark Submit and the path uh, of your Spark script. So now script is running. We can monitor this using localhost. Yeah, job is finished now. So this is how we submit a Spark job on local, and also we can execute the same job on cloud as well using Databricks, because Databricks provides the Spark environment. Okay, so now we can discuss more concepts. So let me start this. This is shell. Now, uh, Spark is a transformation rich library. It's a ETL tool. So we can cover all these functions. So show function, select function, collect with column, where, drop, group, join. All these functions are available. It's a transformation-based library. If we go to the official documentation, uh, here we can see. So all these functions are available, map function, filter, flat map. So these functions are already available in Spark. It's a transformation-based library. So now we can use these functions to perform our transformation activities. Okay. Aggregate, join, group, all these functions are available in Spark. So let's cover these one by one. So um, first the show function. So show function is to show the data. So let me uh, oh, so first create the data set. So this is the library that we need to import. So first is Spark session is already available. So there's no need to import, but no issue if we put that Spark session. So Spark session object is created. Spark session is a pre-built class that we need to import, and we are giving our job name as the app. In the app name, we are providing a random name to our job. Get or create. If Spark session is there, it will get it. If it's not there, it will create it. That's the purpose of get or create. Now define the schema of your data. So uh, the schema is this. So we have two columns, sequence number and code. Okay. Now prepare the data. So in the data, we have prepared similar type of data. So these are key value pairs. So sequence number is the key and code, this is the code, that is the value. So now create data frame. So using create data frame function, we can create our data. So Spark session, Spark session is this object. Okay. Spark session provide a function called create data frame. And in that create data frame, we pass data along with the schema of the data. So now once this function, uh, when we supply these two arguments in this function, it returns a data frame. Okay. So now submit this on the cluster. Your data frame is created. Now you can check the data of the data frame using the show function. So here it will return this data frame. That is kind of a table in a memory. Okay. So now next is we can also pass this truncate. Okay. So it will truncate the characters. Okay. That's a truncated string that it shows. Okay. So if we want to check the content vertically, then that also we can do. Um, yeah, it's not supported here. Okay. In this version of Spark, it's not supported. Okay. Now next function is uh, the select function. Okay. No, so struct type. These are the data types available. So it's kind of a random schema. So let's do this. So for again, we need to import these classes. So as we can see here, so first we import PySpark module. Then from PySpark SQL module, we import Spark session class. And from PySpark SQL, we import the classes like struct field, integer. So in Hive, we studied map. We have also studied struct and array. So in Spark also, we have struct type, this is the class, and struct fields. Now these struct field, the structure fields are called struct field, string type, integer type, array type. So all these data types, you can say all these classes for different data types are available in Spark as well. Now, uh, create a Spark session object. So that is a repetitive object that we need to create every time we are writing a Spark job. So when we write a Spark job, so there are four steps. So first is the environment variable that we need to declare the environment variables. So in the environment variable, we always create a Spark session object. Okay. So how we create Spark session object? So there are two ways in Spark 1.x, in Spark 1.x, um, Spark, there was no Spark session. That time we create Spark context first. This is how we create a Spark context object. This is the core object. Then we create SQL context. Create SQL context. Uh, this is a class. Now we pass reference of Spark context. This is how we create SQL context. And next is the streaming context. So this is how we create streaming context class. We pass Spark context reference here. So these are three environment variable or the objects we have created in Spark 1.x. Now in Spark 2.x, Spark session was introduced. So we create a single object, Spark session dot builder. Now builder is a design pattern that create all the objects that we created explicitly in Spark 1.x. So these objects are auto created by this builder function. So builder dot, uh, we can give our app job as a job name using app name function. So let's say we give Spark test as the job name, and then get or create. Get or create is used to fetch the Spark session. If it's already there on the cluster, it fetch that Spark session. If not, then it create the Spark session. So that is the mandatory object every time we are writing any Spark job. This is step number one. Now in step number two, uh, there's a data extraction step. Okay. So in the data extraction step, next is data extraction. Now in the data extraction step, we create data frames. That is, you can say reading, uh, reading data and create data frame based on that. So df equals spark session dot read dot, if we are reading a CSV file, then just write CSV and then give the path of the file. So let's say the file is on desktop, so prepare, so give that path. And then let's say employee.csv. That is the data extraction step. So in the data extraction step, we it returns a data file. Now, next is the data transformation, because it's a ETL script. So next is data transformation. Now in the data transformation, we apply the transformation function. Let's say we apply group by, join, or filter, or all the aggregate, analytical, these sort of function. So just doing a select of some columns. Let's say ID. This is how we select these columns, and then it will return another data frame, let's say df2, and then we apply df2 dot filter. Uh, now select the column ID greater than 200. So We can apply these functions. Then in the last step, write the data frame in the target location. So for writing, we just need to write, let's say df2 is the final data frame. So df2 dot write dot format, and that in which format we want to write csv dot load, and in the load function, we pass the directory or the URL where we need to keep our data. So let's say we want to store this data in Hadoop only. So we provide HDFS URL. Okay, so this is how we write a Spark script. So these steps are mandatory. This one, environment variable, the first step, and the data extraction, then transformation, and then data loading. Okay, so now first the environment variable. So environment variables means we need to create Spark session object. We have created Spark session object. In the next step, now the data. So this data variable holds the this data, and this data contains a tuple objects within a list. Okay, these all are tuple objects. Now declare schema based on the data. So this is the schema for our data. So we have first name, that is a string type, middle name, last name, ID, gender, salary. So these all are the fields within a structure. Okay. So now this is the custom schema that we have created based on the data. Okay. Now we have data available and it's a schema available. Now we can create the data frame. So this is how we create data frame. So Spark session dot create data frame, and we pass data along with the schema. So it returns a data frame. Now data frame dot show. So it will show the data. So we can see this data frame object is created in the memory. Okay. So, and we can also print the schema of our data using print schema function. So we can see the first name, last name, and this string type. Okay. So this is how we create a data frame. Okay. Next, if we have a nested data structure, this data set was very simple. There's no nested column. All columns are of string type. Okay. But if we have column inside the column, that is the nested data type. So let's see this data. So here, so in the data we have, so first is the tuple object, and this tuple contains tuple only. This is nested tuple. Okay. So now create schema based on this data. So this is how we create schema. So first, this this is first column, and first column is of type struct. And in this structure, there's a field. This whole schema, this is of struct type. Okay. In this structure, there are four columns. The second, third, fourth column, these are straightforward columns. These are the string columns, as we can see. The ID column, that is of type string. Gender is of type string. Salary is of type integer. But the first column, name column contains sub columns. So that's why we define name data type as struct type, because it contains sub columns. Now, in this structure, we have first name, last name, middle name, last name. These are the three sub columns within the name column. Okay. So submit. Now create data frame two. So here Spark session dot create data frame is the function. Here we pass the data. This is my data and the uh, corresponding, you can say the schema based on our nested data. So once we pass data and schema, then it create data frame function, it returns a data frame. So it returns data frame 2. Now we can print the schema of this data frame. So here we can see the data types for uh, this data frame. And also we can print the, okay, sorry, data frame 2. I print data frame 1 schema, print data frame 2 schema. So here we can see the nested structure or nested schema. So name is of type struct that contains 3 fields, and the ID, gender, salary, these are the straight fields without nesting. Okay. Now we can check the data. So data frame dot show. It will show the data of this data frame. So here we can see the name column and the ID, gender, and salary, the other columns. Okay. So that is for the nested data. Now we can use struct also in place of struct type. Okay. So let's implement this. So whatever function we are using, those functions are available in this module. So PySpark.SQL module is the base module, root module, and inside it, it has function class, and that function class provide these functions like call, struct, when. So just import those functions, now apply. So here what we are doing, we are adding a new column in data frame 2. So data frame 2 contains 4 columns. So with the column function, this with column, add a new column, and that column name is other info, and the value of this column is this. So uh, column ID, so value of this column is a struct, and that struct contains these 3 columns. So ID, gender, salary, and giving alias to these columns. Okay. And based on some condition, we assign the value on this column, the new column. And condition is if the salary is greater than less than 2000, then add low value as low. If the salary is less than 4,000, mark that a column value as medium, and otherwise high, salary high. Okay. And then drop the existing column. So let's execute this. Now updated data frame dot show. So here we can see the value in the other info column. So here it marked as salary as low, and it's returning a structure. And in this structure, we have ID column, we have the gender column. Okay. We have the salary column, and in the salary column, we apply these conditions. Okay. So that is how we add new column based on the condition in a data frame. Now we can see the schema of this data frame dot using print schema. So this is the schema. Both columns is of type struct, and this structure contains these columns. Now next is use array. So now declare a schema. This is the array structure. 1 minute. Okay. So okay, this is the custom schema that we are defining. So struct type contains the first field. Struct field name is the column that is of type structure. So the structure contains these three columns: first name, middle name, last name. Hobbies is of type array. Properties is of type map. Contains key value pair. So this is the structure, and basically we have three you can say type of three data types majorly: array type, map type, and struct type. Okay, and why it's a fail? It's because the import uh, we didn't import array type. Okay, import array type. Yeah, this one. We need to import these classes, otherwise failed. Okay, so we'll see this schema, nested schema use case for especially for array in next example. Okay, so let's see this example. This is the data file that is here. Okay, this is the file. So now download this file and create data frame. The file is downloaded. Now first, this is the object, Spark session object that we create whenever we are writing a Spark script. So just create a data frame. Uh, Spark session object. Get of create. Uh, so create this object. Uh, Builder object is not callable. Okay. Yeah, this Spark session is already there. There is no need to create this object. Now read the data. So give the path. So your path is in the downloads. We have zipcodes.csv file. Okay. Now it will return a data frame. So data frame dot show, and this is the data frame that's created. Okay. Now, so now print the schema. So these are the columns, and all columns are of type string. So there are multiple ways to read the data. So here, what we did, we write read.csv. We can use load function as well. So spark.read.load, yeah, spark.read.format. In the format, we can provide CSV file format, and then load function. So data frame dot show. So, so data frame dot show. If we write df dot show, uh, it also reads the data. So there are multiple ways to read the data in a from a file. One is the direct CSV function and the load function to read. Okay. So now, uh, so in the when we read the data, we didn't provide any option. So we can provide options so to read the header, or we can skip the header from a file. So those options we can provide. So here, if we see, uh, so spark dot read dot option. So in the option function, we pass header true. So it will read header as well from the data. Otherwise, it skip the header and then path of our file. So data path. So give the path of your data and it returns data frame 2 only. So this is data frame 2 dot show. So this time we have the data, the scheme header as well. So if we print schema, see this header. So this time we have header also that is read by this read function. Okay. Now, if we can provide delimiter also. So right now our data is comma separated. So if data is space separated or pipe separated, then we can provide delimiter option also in uh, while in the options function. So in the options we provide delimiter as comma. The comma is by default there is comma, but if there is another file format, or you can say delimiter available, so we can pass the delimiter like this. There's something wrong. Mhm. Okay, by mistake, two files. Now execute. So data frame 3 dot show. Okay. So now infer schema, that is very important. So infer schema means, so in the earlier examples, we have created our own schema, custom schema. Custom schema means the schema that user creates. But in Spark, there's uh, option available to there's a function available in for schema that auto capture the schema. So if we apply that function, it will capture whatever schema data have. So if we see here, we pass in the option, we pass infer schema true. Infer schema means capture internal schema or the raw schema that the data have. So that same schema we captured using this property. So pass the path and now return data. data frame 4 dot show. So now df4 dot print schema. Um, it should read the schema. Mhm. Let's execute this. Header true, infer schema true, delimiter is comma separated, and then path of the file. If y dot show. So this is the header that it reads. Now this time it's read schema as well. So that schema is captured using a inbuilt function that Spark provide. Okay. So this infer schema to capture the auto schema or the schema that data have. Okay. So now this is the custom schema. So when we see this schema that is showing here, so it's auto captured using infer schema function. So, but we can create our own custom schema. So let's see how we create the custom schema. So this is the data file of the zip code. And now just define the schema based on this data. So this is how we define a custom schema. Okay. So we have record number, zip, city, state. So here we define the data types for these columns. Double type. So this class. So we should. So these are, as I said, these are the classes available. So integer type, struct field, array type. So we need to import these class every time we are using these classes in our Spark code. So just import this class. Uh, where is the we import this class in the above code? Ah, mhm. Yeah, this one. So copy this and here we can write double type. So these all classes are available in PySpark SQL. Okay, now we can define the schema. So struct type contains all these fields. So some fields they are of integer type, some fields they are of double type, string type, boolean type. Okay. Um, Now it's failed for boolean type. Oh, not failed. So import is not available. So let's import. Type boolean type. Okay, now schema object is created. Now apply this schema on the data. So Spark session dot read. So we are reading data from a CSV file. Option header true. It should read the header. And in the schema function, we are passing our custom schema that we have created. So this is the custom schema object that we have created. So we pass this custom schema object here in this function. And in the load function, we pass the path of our data. Now execute this. Now it returns the data frame. Now data frame dot print schema function to check the schema of this data frame. This is the schema for the data. And now check the uh, data on this data frame. This is the why it's showing. There is some column we do a mismatch. Okay, no worries. So this is how we create a data frame with a custom scheme. Okay. So now we can write the data, as I said, reading data, doing transformation, and the writing the data or loading the data in a target system. So using write function, we can do a data frame load. So data frame, let's say this data frame 5 dot write, and then header true and the CSV function, and provide the path of your data. So now this data is written into a file. Okay. And that is test.csv. Test.csv. Where is test.csv? Downloads. Not here. We can write on desktop as well. With the desktop path. Now write the file. So now check. Yeah, this is the file test.csv, and it has written this part file. Okay. So if you open this file, we can see the data in this file. So this is how we write data frame to a target system. Okay. Now we have four, these are very important same modes. Okay. So what are same modes? Same mode when we use same modes when we are writing the data in a target system. Okay. During the write operation we use. So override means so as we can see here, this is the file. On this one, this file is written. Okay. Now if we if we do an incremental load, if we rewrite the data, so there are four options available. So if we use override, so it will completely remove all the data and rewrite everything. Append is just to add the extra records. Ignore, if file is already there, that ignore error, it returns an error. So let's see append and override case. So um, let's update something in your data frame. So add one more column, df5 dot, using with column function, we can add a new column. So let's say common column name is a test column, and the value of this column is, there's a function lit function. So lit is a literal. So I'm passing a literal value, let's say one. So it's populate this literal one into this test column. Okay. Dot show lit. So we need to import lit. So this one, import lit. I think SQL functions, not types. Import lit. Now we can execute this. So a new column is added. That column name is test, and its value is populated as one. So let's check whether that column is added. Yes, this column is added, and one value is added in this column. Now write your function in the append mode. So data frame in your append mode. Okay. So this is how we write. Use this append modes. So data frame dot write, and then here we use override. So it will override everything and the path. Now execute this. Um, what is name? Brings them it still exists. Fail to delete file or directory. Okay. If we do a append, let's see. See, append, because overwrite mode rewrite everything, but in append mode it's just adding the data in the file itself. So if we open this and check whether that record is that, So it created this new file. Slowly. Okay. So that is the use of append and override. So override everything into override of everything, and append is just add the newly added record. Now whatever we have executed so far on the terminal in the shell, this is interactive shell just for the learning purpose. Now we can execute, we can submit this script or code or the steps that we have executed on a remote cluster. So first, we need to create our job. Okay, so let's create a job for this. So put everything in a Python in a PySpark script. Okay, so this one. Now put everything here, and here just change your data path. Change the data path here. Now save this file. So we need to change the path here. Save this file and save it as spark schema dot py. Save it. And here, this is the script. Now we can submit the script on Spark cluster. Now Spark submit. Now let's submit. Now this Spark is submitted on Spark cluster. So it's running. Now you can track this job on this URL. So here we can see the stages, the storage. Um, I think job is failed. Failed. Okay. It's failed. Mm, maybe just check. So it's first we need to delete. Let me give the different file path. Ah, so sending that one. So let me change the path. Let's- Okay, let's continue on the next topic. So now we have written, read the file, do transformation, and write the file in CSV file format. Now these are pre-built function. So when function, so first create the Spark session object. So here we'll create a Spark session. Mm, Now these functions are available in this module. So PySpark SQL is the module and dot function. This is the whole package that contains all the functions. If we use PySpark SQL types, so it will provide all the classes related to the various data types. Okay. Now create a data frame. So here, what we are doing, we are adding a new column, a new gender, and in this column, when based on the condition, we are adding a value. So if gender is male, adding male, gender is female, adding female. If gender is null, then mark it blank. Otherwise, fetch the value that is already there. So, but before that, we need to create this data frame. So let me check the data frame first. Uh, data frame. This is in which data frame? Mm, This is one data is there. But for this case, when is click here. So first create this data. So next is the Spark session object, Spark session, and now create a data. So this data contains tuple objects within a list. Now define the columns based on the data. The column names are name, gender, and salary. Now create data frame based on the data in schema. So data is here and schema is here. So df dot show, it will show the data. Okay, now add a new column. In order to add new column, we use with the column function. So first, because we are going to use this with function when function. So first import this function. So import when function, and now in order to add a new column, so here what we are doing, df is the existing data frame. So in the data frame, just there's a function with the column. So with the column function, we are adding a new column name, and its value is populated based on these conditions. When otherwise, it's like a switch case. So df2 dot show. So this new column, um, the new gender column is permanently added in the data frame, and here for null, it's market blank. And if there is no gender available, then also it fetch the same value. Okay. So this is how we add a new column with a data frame. We can select the column also using select function. So if when we see on df, the data frame that we have created in the previous step, so we are doing a select on all the columns, selecting all the columns, star means all columns. When gender is male, then mark uh, it as male. If gender column contains F value, then mark it female. If gender is column is null, then mark it blank. Otherwise, mark this column as new gender column if it didn't match these three. So let's see. So execute. Now df2 dot show. Now here we can see a new column is added, and it change from M to male based on this criteria. Okay, this is the select. Now we can use a Spark SQL as well. So this Spark SQL function we use. So here we can import PySpark.sql. This is the package. So there are two functions, Python core functions, or we can use SQL-like expression also. So those SQL expressions are available within SQL module. So from here, we are importing expression function and call function. These are two functions available from the SQL module. Now we can apply the similar conditions using SQL function as well. So as we can see here, um, let's so again we are adding a new column. So here in this new column, if we are adding an expression, so this expression start from here to here. Okay. So case is when gender M, then male. When gender F, then female. When gender is null, then this, else this. So case when then. This is how we declare uh, a procedure or function, PL SQL block, it's kind of. So that PL SQL block we are using here on data frame. Now df3 dot show, it will provide the same result. Okay, so this data frame result and this data frame result is same. The only difference is here we are using Spark SQL expressions, and here we are using Python, core Python functions. That's the only difference. Now, the next case, this case also we can execute using SQL. So here also case when then. So here we are selecting all the columns. Now this is the expression, SQL-like expression that we are defining. So in this expression, case is when gender this, when gender F, then female, when gender null this, else this, and we are marking this column as the new column that is India's new gender. So df4 dot now check the result. So here we can say we achieve the same result that we have achieved using data frame functions. So these are SQL functions. Okay. Or we can execute the plain SQL query as well. So just register this as a view. This view is registered in memory only. And now we can write Spark section, provide a SQL function. In the SQL function, we can write our query. Spark session provide SQL function, just write here plain SQL. Now this SQL executes on data frame. So there are three ways. First way is the Python functions. Second way is the SQL function, SQL-like functions. Third way is pure SQL. Using all three, we achieve the same results. Okay, so this is how we uh, use these PySpark functions that are already provided in PySpark SQL package. Okay, so we can add uh, now whatever we have executed so far, we can create a job or a script. Okay, and we can submit it on the cluster. So, so what we can do, mhm, so here we can create the script. Now Just save this script as py Spark script and submit the cluster. So this whole code is executed. Whatever we have executed in the terminal. So using Spark submit, we can deploy our job on the Spark cluster. Any questions so far? Hello. Anyone else having any question? Hello. Any question? Do we execute the same code in Cloud terminal? Yeah. So Spark is also available here. Let me show you. Now here start by Spark shell. Okay, let's do the IP. And connect with Bluetooth. Here start by Spark shell. Spark is also available on Cloudera. The only difference is it's on Cloudera version 1 is available on 1.6, and the one that I have set up, this is version 2. So some feature might not work in version 1. That's the only difference. Okay. Another session is running. Let me check. Mhm. So here, uh, Shaitan started, but it's throwing bind exception. Maybe some other Spark session is running. Okay, no worries. Mhm. some other Spark session is running. Let's do it. This is one point. So we need to create SQL context first. Then only we can create a data frame. Hmm. I hope you guys understand. In Spark, in Cloudera also, we have Spark session. So we can launch Spark session and execute the code here. We also have this uh, Databricks that I have shown. Databricks, where is Databricks? So this is Databricks. Here also we can execute our Spark code. Okay. I think our cluster is stopped now. It's stopped. Create one more cluster. So it stopped after, if there's no activity within 1 hour, so it will automatically terminate. So launch the cluster. And now we can practice these scripts. So as we can see, the create data frame, these all are PySpark scripts. Okay. So we can submit this. So we can, let's understand this code. So let's creating data frame. Either we can submit this script on the cluster. So it's downloaded. Now go to the location where this script is downloaded, and now we can submit this script on the Spark cluster directly. Okay, and if we can see here, these are PySpark libraries that we need to import. So this bundle, it has the data types, function, it has all the functions that are available in the SQL module. Okay, so here we define the custom schema. This is our data set, and this is the object that we need to create every time we are creating. Um, so we are creating a Spark script. We need to define the Spark session. And now here it created RDD that is converted into data frame using two data frame function. Then we can check the schema. Okay, so let's we can execute these code in interactive shell also, but here it takes time to, we can do a one line into execute. So here we find the data in the columns, then the Spark session object, and then converting the data frame into a RDD. Now it's converted. Now we can check the data of the RDD. Okay. So that is for creation of Spark data frames. We can print the schema also for this. Using print schema function. Um, these all are the steps. So leading CSV file we already covered. Let's cover more functions. So now I'm covering important functions only. So lit function, adding a literal. So if we are adding a new column, So let's say this is my data set. This is my data. Now define the schema corresponding to this data. And now create a data frame based on the data and schema. So div dot show. So it has two columns. Now, if you want to add one more column, so we can use alias or we can use literal. We can use alias or we can use with column. So here we are going to use these two functions, call and lit. So from the above data frame, we can select the employee ID column, salary column, and this literal we are adding into a new column, lit value one. So alias is temporary, with column is permanent. So here we can see a new column has been added and the value of this column is populated as 1. So as I said, using alias also add the column, but this column is temporary only. But if we add a new column using with column function, that column is permanently added to our data frame. That's the only difference. Okay, so now it's showing the lit column with column function. So here we import when, lit, and call. Now add a new column using with the column function. So here we are adding a new column. The column name is lit value and based on the condition. So when the salary greater than equals to 40,000 and salary greater than 50,000, then add this value as 100 into this new column. Otherwise, add 200. Okay, so these two, and now this column is permanently added. So if say dot show, and if these are Python functions, we can use SQL-like function as well, using SQL expressions. Okay, so now we can see a new column is added using this with the column function. Now here it's adding a constant value. Check. So again, same thing we are repeating, data and columns. This is my data frame, and now adding a new value. So we are adding a new column with the value 1. Okay, the column is added. Next is next function is with column rename. So it will do the renaming of the column. So let's execute. This is my data. So this data contains the list that contains a list objects, tuple objects. Now define the schema, custom schema for your data. In order to define the schema, first we need to import these classes. These are the classes available for defining the data types. Now define your custom schema. So our data is nested. So it has a name field that is of type struct. So it contains three fields, and then the rest DOB gender, they are of string type. Okay. So let's execute. Schema is created, a custom schema. And now create a Spark session. It's already there. So create data frame directly. And tf dot show, check the result. Okay. Now check the schema. So it has name, DOB, gender. So now if you want to rename our column, so we can see two columns are of same type. The data type is different, but column names are same. So let's rename this column. So how we rename using rename function. So here we can see we are renaming this. So we rename the column DOB as date of birth and then filling the schema after that. Okay. We can rename multiple columns as well. So now df2 dot show the print schema. So here we can see salary column is renamed. Yeah, what happened? There's no salary column here. So first name, last name. So we can rename other columns. DOB is there. It's already renamed as date of birth. We can rename other columns. Okay. So and now we can create our full script and submit on the cluster. So that is for column renaming. Where and filter clause. So these are the functions we can do using SQL as well. But here we are using Python functions. So first do I import. Now these classes are imported and now define this data first. We can read data from a file or we can declare using collection as well. So this is a list. This list contains the tuple, and inside tuple we have tuple list and the direct string column. So this is nested schema. So now we need to create a custom schema based on this data. So this is the custom schema. So here we can see name column is of type struct that contains three values, first and last name. These are sub columns. And then the second language is of type array. And in this array, we contains string type of values. And the state and gender is the flat data types. So your schema is created. Now based on data and schema, we can create a data frame. So using create data frame function, we can create the data frame. Now data frame dot show, we just first print the schema. So here we can see name is of type struct, language is of type array, and then state and gender. So we can check the result. Okay. So language contains array, language is of type array, names is of type struct, state flat, and gender flat column. Now we can apply filter condition. This is how we apply filter. So here we are filtering where state is OU. Okay. Let's check the result. Okay, now it's showing the result for OU state only. So uh, we can select our column using. So here we are directly calling our column name. We can use call as well. These are expressions. Okay. So now when we are selecting states, we are writing call. That is that is Spark SQL sort of functions, and then show the results. So output of both are same. Okay, same results. Now we can use SQL expressions. So this is a again a filter condition, but the SQL like expressions. So just simple write filter gender and so here we can see the results. We can filter based on multiple columns and using AND operator. Okay. So now it filtered based on the two columns. This one. Now next is filtering based on list. So here we are providing a list. Okay. This is the list contains three values. And now applying filter. So data frame, then selecting state column is in this is a function. And this isn't function checking this list of states within this data frame. So here we can see OU filter out this only. There is no match for C and D. Okay, so this is the filtering of list. So next is starts starts with. So these are just string like functions. So if data frame states starts with N, then filter out. So it filter out the state that starts with N, New York. Okay. Now ends with the states that ends with H. So it filter out the states that ends with H and contains, just check the states contains H character. It filter out those states only. Yeah. So all you and now are like, so this are like or like functions, these are available in SQL as well. So use those functions. Now we can filter on any array column. So for this, we need to import. This is a new function. So we knew that all the functions are available in this package only. So just import it and then apply it on data frame. So we are applying the filter. So this array contains, if the array contains Java, then filter out the result. So we can see here it filter out two records for the arrays that is having Java string, Java, you can say string. So we can filter based on the nested uh, struct. So this is a nested struct. So name is the outer feed column, and then the last name is the inner column. Okay. So now we can write the full code in a script and submit it on the cluster. So I hope you guys understand how we write Spark jobs, whether your Spark environment is available on local or it's available on cloud here also. So here just use your create your notebook, and then you can execute your code here. So let's execute um, this code. Now use this code and execute in this environment. And your cluster, attach the cluster. Your test cluster is here, and now run it. So here your job is submitted on this Spark cluster. So on local also, using Spark Submit, you can run your cluster. And if you are learning, you can execute your code in the interactive shell also. It's for the learning purpose. So here we can see our job is running on the cluster, and it's just printing out the results. Okay, we can see the result here. So this job is finished. Any questions so far? Will you show us how to download in Spark 2 in Windows? Okay, so download Spark from here. Download Spark, second link, and here this one, Spark 2.2.1. Click on it. It will be downloaded. After downloaded, just place your software in any drive. So here I have placed it. After placing it, just open environment variable, and in the environment variable, just set the path. So first, prerequisite is on your system, Java should be there and Python should be there. So Java, this is the Java path I have provided. So this is the variable Java home, and this on this location, my Java is installed. Then provide the Spark path. So Spark home is the variable, and this is where I place Spark. Press OK, OK, and then start Spark. This is how we install. From CMD, just need to write PySpark, and your PySpark shell is started. Understand? This is the installation. Okay. So it's failing because our another session is already uh, the shell is already there, so that's why it's failing itself. Okay. Any other question? Any other question, query? Okay. So that's it for today. We'll continue on Spark tomorrow as well. And uh, it's a vast, you can say, uh, in Spark, there are a lot of concepts available. So tomorrow I will cover advanced level concept like optimizations. So these are important. Rest the common functions we have covered, and it's similar to SQL-like functions. Okay. Mm,
Thank you, Ravi.
yeah. Thanks. So I'm
Yeah,
dropping off. Okay.
yeah, sure. You can.
Okay. Thanks, everyone. See you tomorrow then.
Guys, hope you enjoy the session. If there are any queries, please let me know in the chat box. So I'm sharing the attendance link again in the chat box. Please make sure your attendance. And so I hope there is no more questions. So we'll wind up the session for today.